and Learn series. So Andrew is a John Harvard Distinguished Science Fellow, and he runs a lab in the Center for Advanced Imaging over in the Northwest Labs building. And his lab studies really interesting questions about protein organization and dynamics. And today he's going to answer a very frequently asked question about how to analyze your data, how to build pipelines to analyze your data. We've had a lot of requests on a lecture of this topic, and so we're really excited that Andrew decided to build a speech for them. So thank you, and welcome.
Sure, thanks, Erin. So yeah, I'm over in the Center for Advanced Imaging, and just a quick word that we're not actually a competing facility with HCBI. We're actually like a research center. So as Erin said, I'm very interested in chromatin dynamics, so if you want to talk about single particle trajectories, come to me afterwards. But today, as Erin also said, I want to go really back to basics and talk about like technically how to analyze images and how to make maybe your life easier. So this is sort of an overview of the field of what you can use to do image processing. Most of you probably have used ImageJ. Has anyone ever used IC in the audience? Are you French? No? That's surprising then, because IC is an image analysis software that has a lot of capabilities, but is little known outside of France. Probably most people have used Cell Profiler, right? How many hardcore Python guys do we have? We've got 1, 2, so not so many. How many actually use scikit algorithms? Probably, yeah, you probably just do it yourself. How many Amaris users? A few. Do you like Amaris? Yeah, good. So today I want to talk to you about 2 additional things. One is going to be KNIME, and the other one is a program called Ilastik. Just going briefly through, like, you know, what these different software are actually made for, because they're all serving different needs. So ImageJ, as we all know, is your standard image processing software. It's open source. It's got many different plugins. It's got really great development. And on top of that, you know, you can add these update sites where you can just basically get a command for whatever function you want to perform in image processing. IC, on the other hand, is serving a similar sort of need. As I said, this is also open source, developed in France. It's nice that ImageJ is actually built into this IC program. And what made this software kind of outstanding at the time was that it has graphical programming with protocols. So you can build up these workflows using these variety of nodes. However, in my opinion, KNIME does this in a much better way. It has some plugins for specific features, particle tracking, not as many as Fiji. You can run a microscope with it, which is rather cool, and it does have decent development as well. Of course, many of you have probably used MATLAB to do analysis, right? It's commercial software. You've got the image processing toolbox, so you can just call on anything to do whatever you want. So it's very flexible, well documented, and in Python, of course, you're only limited by your ability to code. Cell Profiler is probably, if you guys have used any analysis workflows or pipelines, you've probably used Cell Profiler, coming from the Broad Institute. It does 3D now, which was a big problem in the past. It's only really good for quite straightforward analysis pipelines. Once you get a bit complicated, you run into some trouble. And of course, if you're a Python guy, you can call everything from scikit. So the first program I want to talk to you today about is called Ilastik. So how many of you guys do segmentation? All right, so everyone does segmentation, basically. How many of you are using some sort of machine learning for segmentation? Can I ask what you use to do your machine learning?
I use segmentation and machine learning.
But what software are you, which program do you use to do that? MATLAB, okay. So this is basically trying to do the same thing. You can run this program in headless mode through MATLAB if you choose. But this is really aimed at the guys who don't know how to code or don't have experience with machine learning algorithms. So it's open source, it runs on Windows and Mac. And its idea is to do a sort of learning style segmentation. So this is supervised pixel and object level classification. And the idea from the logo you can see is that you're meant to paint with labels. So I'll go in through what this actually means, but a really great alternative to this program is actually Weka for ImageJ. It's also performing the same sort of supervised learning segmentation stuff. So let's start with this particularly ugly image of some lipid droplets. So this kind of image is typically pretty hard to segment. If you just did this manually, you could apply some filters. But if you wanted to segment out these big lipid droplets from the background, it can be kind of tricky. With Ilastik, what you can do is create a couple of labels. So say one lipid and one background. So we would label the lipids here in yellow, the background in red. And then you can select a number of different features that you're going to use the supervised segmentation to learn from. So these features include things like the color and brightness, but also the gradients within the image to segment on. And on top of that, there's a number of different textures as well. So if some object has a special texture, looks a bit bumpy, you can also use this to train the algorithm. So you can just select these textures. Okay. So then the painting is literally like painting. So this is rather poorly done, but done quickly. Here I painted the lipids in yellow, and I'm training my image up so that the background is going to be red, and I'm calling everything background that's not one of these big lipid balls. So once you do this painting, you don't have to paint too many images. That's one of the advantages with these programs. Say you build up a library of like 5 images that you've painted, and then you use that training data against like an image library of 1,000 images. Anyway, what you'll get out of this is something that looks like a probability map. So you get these sort of yellow labels and lipids, and then red. And this worked quite well. It was just from this simple little training. It took 5 minutes, you know. You get a nice probability map. On top of that, you also can generate uncertainty regions. So everywhere you see blue is where the algorithm is becoming uncertain about which label to apply. So you can actually go in and then come in with your little painting tool and go along the edges where there's some blue to sort of train up your algorithm better, right? Okay, so in a nutshell, that's how Ilastik works. You can do a lot more with it, and you can get really comprehensive segmentation. I want to pivot now into how we would actually use one of these probability maps. So because you would get this, and what do you do with this? So let's talk about KNIME. So what's KNIME, and why should you care about it? Has anyone here used KNIME? No. Okay, that's not unusual because this is coming out of the University of Constance. And it came off as like a commercial package in the beginning, and the idea is to do data mining for banks and pharmaceutical companies. But then they sort of opened this up to the academic industry, and now it's become quite popular, at least in Europe, for a lot of image processing. So it's open source and free. You can just download this. You don't need to do anything. It's very scalable, and it's an analysis platform. The idea is that you create visual workflows using nodes, all right? And it integrates really well with Cell Profiler, ImageJ, Ilastik, as I've talked about, but also MATLAB, TIBCO Spotfire if you use this for analysis, and of course R. And then it's Java-based, but you can also run within it Python code and full snippets if you want to. So, oh yeah, and one of the advantages, say, to this program as opposed to like Cell Profiler is that it's not just the image processing that you can use it for. It's also good for things like folder manipulation, changing file names, pulling out metadata from XML files, creating XML files, all of these little bits that you would not traditionally get within like just an image analysis work. All right, so you can download it from the KNIME website. Runs on Linux, Windows, Mac. To install the image processing extension, it's very easy to do. And there's dedicated sites where you can download new nodes. So each node is basically a function. So when you load it up, you'll get this very ugly looking desktop, and it's laid out like this usually. So you have a workspace directory. In the middle, you're going to have this workflow editor, and you'll see all these nodes. We'll discuss these in a bit. When you click on a node, you'll get node information over here. When you're running code, you have a console. If your workflow is very big, you have an outline, so this can be expanded. And here's your node library where you can look up functions, basically. So KNIME is based on the concept of nodes, but also tables. So tables contain numbers, of course, images, segmented objects, anything that you have, you can put in a table, essentially. And then you can, of course, call these tables. So 9 nodes. Nodes, as I said, perform different functions. At the top, you usually have like the name of the node. And these are what the different colors mean for running the node. So if it's green, it means it executed successfully. Red, it's not ready. Amber, it's ready to run, but not yet run. If there's a little triangle, it means there's some error. You haven't set something up correctly. And blue is processing. So that's what these look like. A little error, this is ready to run, that's processing. Nodes also run on inputs and outputs. So if you want to connect nodes, you use the input port and the output ports. Very simple, and you're going to connect nodes. If you right-click up on a node, you're going to get a whole bunch of different menus. Essentially, you can collapse certain nodes into what's called a meta node, which will contain like a series of functions. So that then you wrap them together, and then you forget about that little function. You don't need to think about it anymore. Also, if you want to do streaming of processing or some sort of parallelization, this is also pretty useful. So just a couple of examples of simple nodes. So say we have a splitter node. What this one will do in the context of image processing is it's going to read an image column, 1,000 images, and then it will run a simple function. So in this case, it reads an image and then splits it into 3 different channels. Okay, simple node. You also have rather fun nodes that people maybe don't even realize you can do this kind of stuff. Does anyone use regex here? No one. All right, so regex is a way to sort of just, it's a search function that you can use to pull out information in file names or whatever you want. So this regex node, you can enter in this little string, and this function will read from a list of files and then extract a file name from a directory path. So in this case, there would be like a long directory path, then it would just pull out the file name. You can also do that with, there's usually redundancy in nodes, so there's URL to file path or a cell splitter. So you can split, there's many ways to solve the same problems usually. You also have things like just running R inside KNIME. So this makes a little R snippet, but you can do the same for a Python snippet, the MATLAB one. If you want to run a cell profiler pipeline within this, so imagine you want to do some folder manipulations, file name manipulations, then run your already created cell profiler pipeline, and then do something afterwards, like analysis, you could just plug in this node to run your cell profiler pipeline. A few more complicated nodes, things like XML readers. So say you get metadata, you've just done a high content screen of thousands of drugs, you get a metadata file. Usually that's an XML file, and you can use an XML reader or XPath to grab information from that metadata file and then manipulate it however you want. Things like TIBCO, Spotfire, which is an analysis program, of course, you can write to an Excel table if you want. It's really easy to do parallel processing. So you would just make your node workflow and then put these nodes in between 2 chunks, this parallel chunk end and start, and that will then use parallel processing for your workflow. If you want to do deep learning and you don't know how to code really well, this is your way to get into the field, basically. So there's nodes specifically made to set up TensorFlow and Keras deep learning pipelines. So if you want to try that with your image processing, you can do it here. On top of that, all the functions of ImageJ are built directly into KNIME through the image processing extension, so you can call up whatever function you want, essentially. Image processing function. All right, so let's talk about like a super simple analysis pipeline. So what we want to do here, this is a basic segmentation workflow in KNIME with Ilastik. And we're going to build a pipeline on top of that horrible lipid image that we discussed earlier. So this is what it looks like. Essentially, we start with an image reader, and we're going to output in the end however we want the data to be. Maybe in this case, a scatter plot. So the image reader node is simply going to do that. It's going to take in the images, and then it's going to hand off the images to the splitter. In this case, I'm starting with this multicolor, just color image. At the time I made this workflow, Ilastik wasn't able to work with multicolor images yet. It can do that now, so the splitting step is not necessary. But in this case, the splitter will just split it into these 3 different images. And in this case, we're going to focus only on the green image, because that's what I'm going to be working on, green channel. Then what I would do is I can set up the Ilastik node to read in those probability maps that I generated from my trained data. And it will run and process all of my training data onto my, my data set that I want to analyze. Then we can use an image viewer to sort of view those probability maps, and they will look something like this. So for each label that you get, you're going to get a probability map. The next step then would be to take those split images, to take those probability maps, and in this case, we only care about those lipids. We want to segment out these circles and get their features. Yep.
So does this mean that you've already trained your Ilastik?
Yeah, so I would have done that separate there. But if you don't want to have like 2 steps like that, that Weka plugin for ImageJ is now fully integrated into KNIME, so you could do the training within this. It's just, this is the build workflow actually.
Would it be interactive? Like
Yes, it would be interactive training if you go the Weka route. Yeah. Yeah, so then we can take those probability maps, and because it's a probability map, it's going to be gradients of numbers. So what we want to do is use a global thresholder to turn it into a binary image, right? So we split the probability maps, so you get something like this, and then we turn it binary, so that now you have a binary map. It looks pretty messy, right? There's loads of overlaying little horrible bits. So typically what you want to do when you look at this stuff is that you can use something like a median filter, right, to get rid of all of these extra bits. And then this will also remove, the median filter is also going to remove all the small objects as well. So, just confused because, yeah, the clock's not wrong. The clock is wrong. Just caught me there. Okay, so the median filter can be used to get rid of these small objects. And yeah, after this, now we have all of these clumpy images, and we can do something like a connected component analysis on top of that, right? So now we have all of these clumpy images, but at least all of them are set up to be unique features. So then, of course, the next step is we want to reduce this clumpiness. So we can, there's a number of different ways that you can do this. You could do something like watershedding. In this case, there's actually this node to be a clump splitter. So we can basically just split these clumps up by running this node. And that's what it will look like. So you can run this clump splitter, and it's going to declump your guys for you. And there's just a few parameters that you need to change within these nodes, so it's quite easy to run. Okay, so then now we've got our declumped sort of segmented labels, what would you do next, right? You want to apply these segments back to the image, and you also want to find out the segment features, like how big is each of these balls or some other features related to that. So how we can do the first part of that, which is getting the segment features, is we can use something like a label filter. Maybe you want to remove the objects that touch the border. So this is very easy to do. You can take this label filter, you can just tell it to remove the segments that touch the border. You can also segment out by the size of the objects. So if you still have some objects that are really large, you want to get rid of them, or some objects that are super small, you want to get rid of them. This labeling filter will allow you to do that as well. After that, it's very easy to calculate all the features of the segments. So you can calculate things like area, circularity, convexity, whatever you want to do. Basically, you can select from the segment feature. And that's going to generate a table like this with numbers you can call on. It will also generate a bit mask that you have the information related to each segment, so you can see what it actually looks like. The other thing you can do then is apply those segments back onto the original image, so then you can ask things about like intensity of the image below and this kind of thing. So this is easy to do. So there, all you need to use is the joiner node. So a joiner node is just going to take columns or tables and it's going to join them together. So that's simply what this does. It will join the segmentation information plus the image information from the very beginning. I think did I leave it out? I left it out here, but essentially I would take the image reading from here and then join it over there. Right. So then you get the image segment feature, again, on top of these two images, and you're going to get something that looks like this. So these are all the segmentations. This is the image. And then, of course, you can also now get things like intensity, now that you have this object mask. You can also throw in a quality check at that point. So there's a node which is called interactive segmentation view. And what this would allow you to do is basically look at your images overlaid with the segments, but it's interactive. So because I only trained on one data set, this is not perfect at all. But I could go in here and I could start to select things that are not true if I want to have that extra level of like fine touch. So that's quite useful. So then you can do a bunch of after processing of your data, right? So now you have a table of images. You want to make this into a usable sort of way. So in this case, I use row ID, which is going to create a new image name column. So it's going to allow me to better annotate my images. Because if you think about how this data would be created, it's a big table with different file names. And those different segment features, so each spot in the image is going to be in one huge table. So you want to relate that information to each other. Right? So I can create, from my row ID, create an image name. I can create a new column for the image names, then remove anything that I don't want. So say features I don't want or don't need. And then you rename all of this to make it easier to do data analysis so that you can call the parameters you want what you want them. But that's just meant to be illustrating sort of that you have this flexibility for after processing that you maybe don't have in Cell Profiler. Like you might have to run some other program to sort of generate your file names in the way that you want. After this, so now I have a nice table. Everything's got, so the image features are related to the image name. And from this, then I have a lot of flexibility, right? So if you use your data in Excel, sure, you can create your Excel table and then plot out your figure. But you can also just plot your figures through this program in KNIME. Or if you want to run a MATLAB to like make a MATLAB figure, you can also do that here. This is no problem at all. So in essence, KNIME is this sort of way, this holistic approach to go with any data processing. It's not really only image processing, but you can sort of target many different, if you're doing genomics, there's also a genomics extension, for instance. And it's going to integrate all of your favorite analysis software, so I recommend that you try it out at least. It might save you a lot of time. It's platform independent, which is maybe really important to some of you. And of course, it's free. I think these slides I'll make these slides available on my website if you're interested. If people have like additional sort of questions about this, I can help you set up. I'm not the expert. The experts are here. So I'm not sure if you guys use these forums, but they're really good. It's a great community where you'll actually get some answers. So if you run into big problems with analysis workflows, not only from KNIME, but really anything, ImageSC is just filled with awesome people. Yeah, so I think that's all I really want to say. It's not a super long lecture, but if you have sort of pipelines that you want to talk about, feel free to write to me. If I can't help you, I for sure know some people that can help you, and HCBI as well is, of course, there. If you guys, I'll do some advertising for myself. If you're interested in chromatin at all, I have a chromatin club. If you'd like to join, let me know. We do chromatin discussions. I provide free food to bribe you. And other than that, if you'd like to visit the Center for Advanced Imaging, again, we're not a facility, we're research. We're in the basement of Northwest Building. So with that, thank you for your attention. If you have questions, we can use this for discussion now.
Can you create segmented binary masks between data?
Yep, you can actually. So if you do that with Ilastik, you can load in, so how did you just generate a sort of binary mask somewhere and you want to add it in? Yeah, you can do that already. I think you could already do it in KNIME without going the Ilastik route, but you could call that in, yeah. Sure.
Is it possible to implement the NAND system from very high?
On the what?
From very high.
Sorry. Probably. I think so. I don't see why not. I'm sure it has been done already by someone else, actually. Yeah. I can look that up for you.
Is there any way to have it in a more script-like fashion as opposed to lab view-like sort of images? So one of the great advantages that I see of it is, as you said, you can integrate software that is written across just different programs. But often it's convenient for programmers to have them in a typed script as opposed to these floating little images.
Yeah, right.
Is there such an option for?
I'm not sure if there is. I think there's probably not, just because it's kind of aimed at maybe not a person who's just going to use everything in Python or like is used to a script. But I can also look that up. I'm not sure, but that's probably. I think there's not, unfortunately. You should try it anyway, though.
If you are integrating code from MATLAB or R, you showed that space at the bottom where you can see script. Is that an option to edit things within KNIME that you incorporated, or do you have to go back to R to edit or overlay?
No, not at all. So actually how it would work is that if you wanted to run something from MATLAB, is that you would open up, there's a few ways to do it, but you would essentially open up one of these nodes. So say you wanted to run a MATLAB snippet, you would open up this node, and then you have some configuration areas. And essentially what you do is just copy and paste your code and put it in there. And that's how it would work. The same with Python as well.
Is there a way to go the other way around? So for example, if I wanted to use the self-bump splitter in a script that I call from Python to basically call the KNIME self-bump splitter process.
So in that case, I think that cell comp splitter is on scikit anyway, so I would just go to scikit and grab it from there. You're already too advanced. You don't need. Yeah, sure. I think there's. I don't see it being a useful way to really call KNIME. I think it's rather to use that as the base and then call other stuff. But maybe.
So I had a curiosity, how does it work? So how does it call all these instances of different programs? You have to have the programs open?
You don't have to have them
or
open.
is it-
You need to have them installed, and then essentially in KNIME you can set up outside some configuration settings. So I'll install say I want to use it with MATLAB. There's a configuration setting where I tell KNIME where my installation of MATLAB is, and that's all you need to do. But you don't need to have it open. It's going to call it headless.
Do we need to handle the different format between different programs, different
Ah.
languages?
That's a really good point. So you don't, which is quite useful actually.
So how does it handle like this?
I'm not sure, but I have not run into the case where I have to worry about different formats. So usually once it's in KNIME, you're fine. And then you can change your formats to whatever you want. But yes.
So actually following it up on that, it's a good question, right? So if it wants to transfer some data from one snippet of the code to another snippet of the code, does it save to file, or does it have a way to share RAM?
Yeah, so that you touch on actually really important points, which is like how you are storing information when you're doing the processing. It depends what you're doing is the answer. There's a bit of nuance to it, but sometimes you're going to be saving this and sometimes you're not. It really just depends what profile and work plan you're sort of using, because there's certain tricks you can do, of course, to make sure that you're not saving the files and running out of memory. But it's more nuanced to this. Sure.
And you showed us several snippets.
Yes.
Like Python, MATLAB, and R.
Yeah.
So the developing of snippet is open, so we can sometimes we can develop a snippet into lab view.
It's a good question about LabVIEW. I should have looked it up, but there must be some incorporation into LabVIEW as well. I just haven't used it for myself yet. But this would be open, yes. And there's a large community for KNIME now that's coming for image processing. But I haven't tried LabVIEW. Yeah. Sure.
So you mentioned there's a genomics extension. What kinds of things do you know that people usually use it for?
I think it's mostly sequence manipulation, essentially. I haven't used it myself because I'm an imaging guy, but it's mostly sequence manipulation. There's extensions for crazy different fields. There's a really good one for chemistry as well. There's very good ones for the financial sector, and these are all sort of, you can upload the extension or download the extension, and then you have access to all those functions too. So there's sometimes crosstalk as well. Any more questions? Yeah, sure.
Yeah, practical point, if someone wanted to move into KNIME, what's your workflow? Do you exclusively work in KNIME to sort of start with one image and settle on your parameters, or do you play around in Fiji, get to know what processing might work, and then put it into KNIME, or is it really user-friendly where you get a lot of visual
Yeah.
feedback on how things work?
So the beauty is that when you're using KNIME, it's just a way to organize yourself. You're just running the same stuff that you're running in Fiji, right? So if you want, you can fiddle around in Fiji until you get your processing right and then throw it into KNIME. It's going to be the same functions in the end. So whatever you're more comfortable with. For me, if I'm just quickly checking an image, open it in Fiji. But of course, Fiji is going to give you repetitive strain entries if you try and do a lot of other stuff. Yeah. So.
You can process the movie.
Absolutely.
For example,
So yeah, there's like video viewers, but also anything that you could do in ImageJ, you can also do here. So I've done particle tracking. So I've, for instance, uploaded videos where I have spots moving, then I can call the functions for like TrackMate in ImageJ. Then I can track my spots through KNIME, do it in an interactive way to select trajectories. So there's lots of flexibility. Yeah.
Can you then plot like the
Of course. Yeah. Because plotting an MSD is just, you know, doing the calculation for an MSD and then plotting a.
that you can really that also.
Yeah, because that's just an algorithm, right? It's just a calculation. So you just have a node. So I should have mentioned that, but there's math nodes.
Like what do you have to call like something like that? Because this seems like it's like just putting different things together.
Yeah.
So are you calling like MATLAB or something else?
So you're asking for particle tracking. So for pipelines where I've done particle tracking, I would do the tracking and track. So I'd read in my images. And the pipeline would then use ImageJ to do some pre-processing, use TrackMate, you get trajectories. Then that trajectory data is going to be like XY coordinates. On that, you can run a math node, and then there you are. And then you have your table, plot the MSD. Yeah.
Is there a software so that we can use this on a cloud computing environment?
I'm sure there must be, but I don't know. But I'm sure there must be ways to do it on like a bigger computer. I was talking with image or research computing, and because it's Linux based, you could install it on the cluster and then run your image processing there. You have the visual interface for research computing, so then you would have a lot more power to pump into your pipeline. So, any more questions? Yeah, what kind of single cell analysis? So that's a good point. I haven't tried it myself yet, but I suspect it's probably in the genomics extension. But I don't venture into that field so much myself, but I'm sure it's there. And if it's not, hope to help.
And are there samples like working?
There are. So if you go on to, let me see, you go onto KNIME and then you find the image processing thing, there's actually a series of tutorials just to take you through all these basic points, but also more complicated ones. If you go onto ImageSC, those guys will sort you out like within a day. So yeah. Okay, if there's no more questions, then thank you for coming, and yeah.